Now in this video I'm going to talk about uncertainty propagation. What does this mean? Well, let's say you're trying to measure the energy of something, and we know the energy is a half mv squared. But what you actually measure are the mass and the velocity. And there might be an uncertainty in both of those. So you might know that the mass has got some value with an uncertainty sigma mass, and the velocity with an uncertainty sigma velocity. But what's the uncertainty in the energy? Well, uncertainty propagation is how you take the uncertainty in the different variables that make up some equation and to propagate them to work out the uncertainty in the final result. Now this is a big topic. For the moment we're going to teach you some quick and dirty ways to do it and some cheating methods using web pages. We will teach you how to do uncertainty propagation more mathematically later on in the course. But in practice most of the time it's just perfectly fine to cheat and use the simple methods. Now the simplest method of all is, let's say you know that the mass has some value, and say it's 1 plus or minus 0.1, and the velocity is 10 plus or minus 2. Well, you look at the equation, and you can see that if the mass goes up, the energy goes up, and if the velocity goes up, the energy goes up as well. So to get the biggest energy, it's going to be if the mass is 1 plus 0.1, and if velocity is 10 plus 2. So what you could do is just calculate the energy assuming the mass is 1 and the velocity is 10, which would be a half times 1 times 10 squared, which is going to be 50. And then you can work it out assuming that the mass has got the uncertainty added into it, so it's 1.1. So you've got a half times 1.1 times 12 squared. And I'll use my calculator to work that out. So that's a half times 1.1 times 12 squared, which is 79.2. So what you can see is changing the mass by this and the velocity by that has increased the energy by 29.2. So you can estimate that the energy equals 50 plus or minus about 29. An easy way to do something like this is actually to use the calculate function in a spreadsheet like Excel. So let's say we'll have the mass. I'm going to type an equal sign here to make it an equation because we're going to change it. So let's say the mass is 1 and the velocity, again I'm typing in equals, is 10, and then the energy, and this is going to be an equation, equals a half times, star is times, m times v squared. What I can do now is have a new column where I add the uncertainty. So we can say 1.1 and 10, sorry, let's actually just use equals 1 plus 0.1, and I'll calculate it for you, equals 10 plus 2. And for this what you can do is you can just drag. So you see this little bottom button at the bottom here, pull that across, and what it will do is it now duplicates this only for its own column. And the difference between these two is the uncertainty. So we can do something like equals this minus that, and that will tell us the uncertainty. Now just to check, this is when we made them both bigger by one uncertainty. We'll also make them smaller. So if you look at this, we can do as at 1 minus 0.1, And we can make this 10 minus 2. And you can see the energy has now dropped to 28.8, which is about 21 less. So you'd expect if you increase or decrease by the same uncertainty, you should get about the same change in the final energy. In practice, in this case, you don't. One makes it go up by 28, one makes it go down by 21, but that's probably good enough for most purposes. So this gives you an estimate that somewhere between 20 and 30 is the uncertainty in the energy. And this might be a bit of an easier way to do it than just calculate all by hand and use a calculator, but up to you which you prefer. Now, a more accurate way to do it is to use one of the web pages, which I'll link to from the notes here. Here is one. You can type in the variables. We're going to be using two variables. We've got mass times velocity. So x is mass, and we've said it's 1 plus or minus 0.1, and the velocity is 10 plus or minus 2. You can ignore this. The expression is 0.5 times x times y. And I think I'll check how they do squared. Power. Okay, we need to use power. So it's y2, so that's y raised to the second power. And if we propagate that, it tells us that the answer should be 50 with an uncertainty of 20.6, which again is roughly consistent with everything else we've done. So feel free to use any of these methods, use the website or just try plugging in the numbers and see what happens. That's good enough for the moment. We will teach you a more precise method, well, not more precise, this calculator here is very good, but we'll teach you a way to actually calculate equations for the propagation of uncertainty a bit later in the course.